Hey, what's up, guys? Welcome to this video. In this video, I wanted to briefly cover inductors. Why inductors? Because inductors are the third leg of the fundamental components. So they are typically considered a very challenging component to understand, but it doesn't have to be so. The reason why inductors get a bad reputation is because they're usually thought of overcomplicated, mathematics and not from a practical standpoint. Now, many modern resources, dive straight into dense, complex maths. And that level of detail is necessary when you start to design highly efficient DC to DC converters, or when you start doing, very powerful switch mode power supplies. We will cover those stuff in this series. But, for this basic electronics and embedded systems, the level we are at now, we basically think of the inductors, as the symbol is, as a coil or wire. And the inductor is another component, just like a resistor capacitor. But in my opinion, is one of the most valuable components to master. Because as electronics continues to evolve, understanding how to work with inductors, especially in things like power supply design, audio circuits, that kind of things, will become a goal and skill. And the great thing is, inductors actually easier to use than capacitors because unlike capacitors, which are polarized, a lot of capacitors we use are polarized. Um, inductors are not polarized, and you can create inductors out of anything. You can just coil up some wire and create inductors. So what exactly is an inductor? An inductor is nothing more than a coil or wire, right? Just like the symbol is. It's just a coil or wire. And you want to represent, inductors as with L, and that really stands for the amount of henries the inductor is. So, you know, um, inductors come in all shape and sizes, but the kind of inductor that I really like is the toroid. So a toroid is like this kind of this metal, this powder kind of iron toroidal shape here, like a donut shape. And these are my favorite type of inductors because the amount of inductance my inductor has kind of depends on things like the number of turns in the coil, the diameter length of the coil, and the material which it is wound, right? And if you do like air wound inductors, they will have some power, you could use them, but when you really start to put toroidal inductors into play, you really get a very powerful inductor in a very compact package. And this guide I went through a lot of stuff, but I just really want to show you how we actually use these inductors. So I have this circuit set up here, and this circuit is a boost converter circuit, right? And you typically see these in all over the place, right? Typically they'll replace the switch here with a microcontroller. Now, a boost converter like this, it's designed really simple. So basically, when the switch is closed, current will flow from your voltage source through the inductor right to ground, right? Um, Now, during this phase, the inductor will store the energy in a magnetic field. So that's what I want to get across to you guys, that an inductor is nothing more than a different way of storing energy. Just like a capacitor, inductors also store energy. That's all it does. It's just that instead of using the dielectric, it uses a magnetic field to do the storage, right? And when the switch is open, all the energy that the inductor store, remember that's like we did the capacitor was charged up, and then when we remove the power, the capacitor was pouring the circuit in the same way. When we open the switch, um, the inductor release all the stored energy, causing a voltage spike that is higher than the supply voltage, right? And when you start working on power supply stuff with microcontrollers, with motors and other inductive circuits, you'll see that this is a dangerous property of inductors. It tends to create a big spike, but it's also a property we could exploit for things like boost converters and things like that. So because the diode here is reverse bias, it prevents current from reaching the capacitor. And when the switch is open, the inductor creates this huge spike, and it will charge the capacitor. And the capacitor now will just maintain a higher voltage than the input supply. Now, this is a very, like I said, a useful circuit. They see it all over the place. They'll have something like Arduino here. They will have some kind of analog component of something like that. But this type of circuit is only good for demonstration because it doesn't have any feedback, right? When you're doing power circuits, you really want feedback. One of the modules I want to cover with you all will be power, power electronics, but this circuit lacks feedback. So I could demonstrate this circuit. So we have this circuit here actually. So I actually have this I should probably show you different types of inductors you'll come across. So the inductors you typically use, I use these a lot, these are kind of shielded power inductors. But you also see inductors that kind of look like these resistor type packages. You see inductors that sometimes look like this. They're all different types of inductors. And the one we use, I like the toroid. So I have this wound toroid here, right? And I'll actually place it in circuit. So if you want to build this, you actually use the toroid, right? And you actually want to use magnet wire, right? There are different gauges of this now for basic, experimenting and stuff. 22 gauges are a nice fit because it fits into our breadboard really well. 24 I find it's a bit too thin. When you start to reach 20 and 18 and stuff, it's a little too thick for breadboard stuff. But if you have to buy one size, I generally recommend either 22 or 18, right? Even though 18 it might necessarily fit in our breadboard. So what we'll do is we'll actually connect this inductor here, right? So show you inductor is connected. Right, you get inductor in. Now this inductor really so not tightly wound, but I just had it one like this just to demonstrate, right? Here we are, we power on the circuit. Right, so you see it's at 4.6 volts, right? And if we actually close the switch, we've closed it fast enough. We actually see we get this jump, and it could jump all the way to fast everything. It could jump all the way to 9 volts. And I want to share with why I need this tight wounding because because this isn't really too tight. That's just the capacitor holding charges to quickly discharges. If we use this is a shielded inductor, like when I show you, I mean it's much better designed. I will actually place this in the circuit. Let's get this right. Also raises it, and we could also put the regular inductor. And let's put the regular inductor, right? And we press the regular kind of resistor shape inductor. Also again good down. Also again good current. So that's it, guys. That's how inductors work. And thanks for watching. Be sure to subscribe, and in the next series of videos, I'll move on to semiconductors, and then we'll get into some power circuits, electronic circuits, and microcontrollers. Thanks for watching, guys. Be sure to like, share, and subscribe.